Hello and welcome to the very last lesson on my series of lessons on the topic of formula and variation. Before us is yet another example that has to do with joint variation. And so let's move through the question. We told three quantities A, B, and C are such that A varies directly as square root of B and inversely as a square of C. Now given that A is 4 when B is 64 and C is 5, find the law connecting A, B, and C. We begin with that. Now, we're given the values of A, B, and C, but we're also told that the three quantities are such that A varies directly as a square root of B and inversely as a square of C. And therefore, that tells us that we can write it this way. So that A is proportional to root B, but inversely proportional to square of C, and it's jointly. Again, this expression can be written this particular way as an equation. Now, A is equals to K root B all over C squared, where the proportionality sign has been replaced by equal sign and K, like that. Now, since we have been told the A, B, and C values, we use them to find the value of K so that we get the law connecting A, B, and C, which will be the answer for Roman 1 of part A. And so putting the values in this particular formula, we're going to get the value of K as by simplifying that, the value of K will simply be 12.5. And therefore, the formula connecting, which is the general formula, general law, is this particular one here, only that K is replaced by 12.5, which is going to be simply A is equals to 12.5 root B all over C squared. And that is the answer for part A, Roman 1. Moving on to Roman 2, we're told find the value of A when B is 16 and C is 10. So just put the values in the formula that we just obtained. Formula being this other one here, this one here, replace B with 16 and C with 10. And so you could get 16 root of it times 10, then there's 10 squared over there. So you simplify. 12.5 times 4 all over 100, the answer will be half. And that is the answer that is expected in Roman 2 of part A. We move on to the exciting part, which is part B. Now we told that if B is increased by 44% and C decreased by 20%, find the percentage change in A. Now, originally we should know that B was 100% and C was 100%, but B has been increased by 44, so it's 144 over 100 of B, and C is decreased by 20%, so it is 80 all over 100 of C, so 80 of 100 C. And so the formula originally having been like this, it's going to be like this. The adjusted A, let me call it A1, is equals to K 144 over 100 of B, then the square root of that, and then 80 over 100 C, the square of that. And our business now is simplify the values that you have there. And so we're going to get K, then the square root of 1.44 B, and 0.8 C squared. And simplifying that further, you're going to get the square root of 1.44 is 1.2. Then 0.8 squared is 0.64. And then you remove the numbers so that we have the K, the B, and C after that. So that I have 1.2 all over 0.64 K root B all over C squared. And this is a better looking way than the way it looked like at the beginning here. Now, simplifying further, we can get 1.2 divided by 0.64. You get the answer is 1.875. Now, please notice that our original A was K root B all over C squared. And that's what we have here. And so I can say A1, adjusted A, is the same as this figure, 1.875, then an A there. So 1.875A. And therefore I understand that A1 is simply 1.875 of the A. The question is, so what is the percentage change? A student should be able to see that since A was originally 1, now it is 1.875, the change has been an increase of 87.5. It's almost possible to see that even without calculating. And I think the examiner would just want to see that. However, for the sake of explanation, I go about it like this. I say divide both sides by A so that you get A1 all over A is equals to 1.875 all over 1. Then I say if A is 1, or when A is 1, A1 is 1.875. So what's the change? percentage change would be what we have now, 1.875 minus the original, all over the original, times 100. And that's going to be 87.5% increase. That's how you should go about the question. However, when a student gets to even this point here, that A1 is equals to 1.875 K root B all over C squared, they should be able to give the answer right away at that particular point. So that brings me to the end of that particular lesson, and also all the lessons that I had on the topic of formula and variations. Please check out for the next topic, which has to do with sequences and series. I intend to do a lot more. So please like, share, subscribe. I'll appreciate it. Thank you.